Okay, well, good morning, everyone. Let's get started. I'm going to try and keep this list from time to time here so you can see it. We're on to our next section, which is going to be our final section for this week, substitution rule. And here are some integrals that you do not know the answer to. If you look at any of these guys, none of them are on this list. Would you agree? I mean, there isn't anything that's got x cubes and e to the x to the 4. In fact, isn't there nothing with e to the x to the 4? Isn't it just e to the x? That's all we got. Suppose you had to do question 2. The only way that you could do this right now, by the methods that you know right now, is when you have to FOIL that out and do a very, very big power rule. Wouldn't that probably take you all day for one question? And if you wanted to make it look pretty, can you imagine trying to factor your answer back together again after you'd finished? That definitely would take you the whole day. Here's a really ugly square root you don't need to do. Here is a weird trig function, which there isn't a trig identity in the world that would save you. That one is impossible with the techniques that you know. And here's one with a fraction and a log, if that wasn't bad enough. And you can't do that either. So we're going to show you how to do them. And the way that's going to happen is by a thing called the substitution rule. If you thought the power rule was versatile, right, in the things that allowed you to, integrate, the substitution rule beats that guy hands down. This technique is going to allow you to integrate huge, virtually an infinite number of functions now. Things that you wouldn't even imagine it was possible to do. You will be able to do them using this technique. So the substitution rule is not a formula, although you can look online and you can actually find a formula for it. The problem is that nobody uses it because the formula really doesn't make sense. Analogy. Remember the chain rule in differentiation? Remember the chain rule? Wasn't the chain rule not really a formula that you could really use? Like the product rule was a formula, right? Couldn't you use the formula in the product rule to do things? But wasn't the chain rule more a process? Right? A function of a function, it was a process. So I want you to think of it in this sense. So here's a question, and I am going to go through this question very slowly with steps. So the first step, called step 1, is you choose an appropriate substitution. What we're going to do essentially is we are going to take this really ugly integral and by a process of substitution, replacing things, we are going to turn it into another integral that's equivalent to this one. But this new integral is going to be a much nicer one, a simpler one, and one that we know the answer to. So we're going to take a question that we don't know the answer to, turn it into a question that we do know the answer to. We're then going to solve that new question and use its solution to figure out what the original problem solution is. So that's kind of the very big picture way of doing it. Now, the typical letter that we use for the substitution is U. So that's why in the future, you'll probably hear me saying U subs. I'll say to you, what U sub will you use in this question? And what I'm saying is, what's the substitution that you're going to use? In this particular question, you're going to use that guy. And right now, you're just taking my word for it. Later on, we'll try and explain why that's the U sub and not anything else. So that's step 1. Now, as I say, I'm taking this really slow. Step 2, you're going to now differentiate. Now, I know this is a calculus 2 class, so you would say, but shouldn't we be integrating in calculus 2? Yes, we will. But you know, sometimes you have to differentiate as well. So let's differentiate this guy. And I'm not going to do u dashed. I'm going to write down that guy. Remember differentiation hat on, right? Multiply by the power, reduce it by 1, right? 4x cubed, that guy. And the reason I'm going to use this notation rather than any of the other derivative notations, because isn't that the notation for derivative as well, is that this format allows me to do this. You then, what I call the crossover. In other words, you can now write this as the differential du is that guy. You then divide both sides by 4x cubed, and I call that step isolating the dx. So you got your u sub, you differentiate it, you do the crossover, and then you divide to isolate the dx. And that's step 2. You differentiate to find dx. Okay. Then we do step 3. We do substitution. Okay, so here's my original integral, right? This guy up here is going to be the integral. I'm going to leave the 2x cubed alone. The e to the x to the 4 becomes the e to the u, and the dx becomes this stuff. Do you see what I've done there is I've substituted the x to the 4 with a u. I've substituted the dx with this stuff. And after you do the substitution, so you do substitution, and then you simplify. And let's see what happens when we simplify. The 2 on the top, the 4 on the bottom gets me a half. The x cubes cancel out, and I am left with that guy. So what have I done? I've taken this original integral that I do not know the answer to. I can't actually tell you what it is, but I have turned it into this integral. Right? It's got a different variable, right? It's in terms of u now, not in terms of x. But would you agree that we know how to integrate this guy? Great. Isn't he one of these standard integrals? So that's step 4 coming up now. And in step 4, you integrate. Well, if you want to integrate 1/2 e to the u, you will get the answer 1/2 e to the u plus c, because it's dead easy to integrate e to the u, isn't it? And now the final step. Step 5. Substitute back to the x's. So instead of 1/2 e to the u, I remember that u was just the same thing as x to the 4, and we're finished. So the original integral, which we do not know the answer to, do you see this sneaky method has allowed me to find it? By turning it into a different integral that I do know the answer to, integrating that easy integral, and then converting back to the beginning. There's a lot, even if the details are a little bit, grey right now, does that general process seem reasonable, how we're going to tackle these kinds of questions? By a method called substitution. So that's the first one you've seen. And I think when something's new like this, especially when it's got lots of pieces to it, you kind of need to see it a few more times. In particular, hopefully 5 times should be enough. So here's question 2. Let's do that one. Okay, I won't be writing down the words, but I will put what the step is. In this question, what do you think the u sub is going to be? What will u be equal to in this question? There's not an awful lot of choices. What do you think?
7.
Does that seem reasonable? Okay, done. Step 2 now. Differentiate with respect to x. You get 10. Do the crossover. Du then is 10 dx. Isolate the dx, and you now have that. Step 3, substitute and then simplify. This guy, right, this fella here is now going to be u to the power 100. The dx is going to be 1/10 du. And they're not really a lot of simplification in this one. Sometimes you have a lot, but not in this one. It becomes that guy, would you agree? The step 4. Integrate. Okay, would you agree this is a power rule? Okay, add 1 to the power. Divide by the new power. Can you trust me? That's what you get when you take this and divide it by that. Plus a c. Last step, step 5. Take your answer, which is in terms of u, and convert it back to x's using this. Substitute it back. So it's 10, 10x plus 7 to the power 101, add c. Now, compared to the only other method that you could use to get that answer, this is a lot more efficient. Because the only other way you could do that would be to FOIL that out. Do you really want to go 10x plus 7 times 10x plus 7 times 10x plus 7, 100 times? Do you really want to multiply that together? I mean, can you just imagine that would just drive you crazy? And that would be only the first step. Wouldn't you then do a whole load of power rules? Can you imagine how ugly that would look? And then lastly, could you even realize that it factors back to that answer? Because it's not obvious it does. Have I sold you on this method? This substitution method does allow us to integrate things that would be really impossible any other way. Two side by side for a second before I move on. When you see these two guys side by side, do you get the flow for the process? The step 1, the 2, the 3, the 4, and the finish. If you can get the process down, you can stick anything you like there within reason, and you should be able to follow it. So here's the third one. We're going to do the integral of x, the square root of 2x squared plus 10 dx. Who is the u sub going to be in this question?
Two x squared plus 10.
Right. As a general rule, don't you try and pick the ugly thing, whatever that means, as your u sub. That makes sense? So what am I getting at when I say the ugly thing? Well, I think x to the 4 is a bit uglier than 2x cubed. In this question, I don't even think I had a choice. Would you agree it's the only thing that the u sub could be? U subs don't tend to be that complicated. They just tend to be the one piece that's really ugly. Now, differentiate. This is step 2 now. If you differentiate with respect to x, you get 4x. If you do the crossover, and then divide both sides by 4x to isolate the dx. Are you getting comfortable with that? It's pretty standard, isn't it? What you do here is pretty much the same each time. So let's look at step 3 then. It's going to be the integral of x, the square root of u, and instead of dx, we're going to have 1 over 4x du. Cancel, cancel, and simplify. And when I simplify it, I'm going to turn the square root into a half power while I'm at it. Are you happy about how this became that? Do you see how it works? Any questions so far? Or are we good? Yeah. Now, can you see that's a much easier integral than the original? Right, this is doable, isn't it? Right, add 1 to the power. Divide by 3/2 is the same thing as multiplying by 2/3. 2/3 times a quarter ends up eventually being a 1/6. Style points. Always style points. That never goes away. So where are we off to now? Well, step 5. Turn that back into x's. So it's 1/6 the square root of 2x squared plus 10 all cubed plus c. There's our 5 steps. Feeling good?
I got a question.
Yes.
In step 2 and step 1, how did you why'd you pick 4x again?
Oh, you differentiate this with respect to x, and that's where the 4x came from. So 2x squared plus 10, when I differentiate it, gave me the 4x. So I'm not sure if that's your question, but that's where the 4x came from.
Okay, thank you.
Okay. Who's my next guy on my list? Here we go. Number 4. This technique is so adaptable. So many different functions that look quite different from each other. You can still use the technique of substitution to integrate them. Who do you think is going to be the U sub in this question? Because sometimes the hardest part of this question is picking the U sub. After that, it kind of flows, right? It tends to do what it does. Who do you think?
1 plus
Matthew?
10x because it has the constant.
That seems like a good deal. Yeah. When you've got a fraction, you know, something over something, it's a good idea to think about the bottom as being where the U sub lives. It's not a guarantee, Joe, but it works more times than it doesn't. Now that I've got, which I know is the correct U sub, I'll differentiate it. And if you differentiate this guy, you get cosine x. Then I'll do my crossover. And then I'll divide both sides by cosine of x to isolate the dx. Are we good with that? So here's step 2. To step 3 now. Substitution, I have 2 cosine x's over u times, instead of dx, I'll replace the dx with a 1 over cosine x du. And now simplify it. They cancel, and you're going to have, well, you can write it two different ways. I'm going to write it that way. You could have called it 2 over u if you prefer, but I'm going to write it that way. Would you agree this guy is easy to integrate? In fact, isn't that guy underneath my piece of paper, isn't he a standard integral? What is that then? Because that's where we are now. Integrate this guy for me. What does it look like? What's the antiderivative of 1 over u? That's what I'm asking.
The natural log of u.
So this is 2 natural log of u's plus c. And then you finish. Don't you just return back to the original? In this case, replace the u with a 1 plus sine x. Do you see my flow? I keep pushing this idea. A 1, 2, 3, 4, 5. It's a process, right? You're like a baking a cake, right? There's 5 steps to the cake. You have to follow the steps in order, but if you do that, you'll end up with a cake at the end. If you jumble up the steps, don't you end up with rubbish? So, there's a direction, a 1, 2, 3, 4, 5 kind of thing. Our last one then. Right now, it's not the last one. We're going to do lots of them. The last one is this bunch. And I've chosen this one because the choosing of the u sub is, for some of you, don't know if you in particular, but for some of you, it's going to be a hard choice. But there is only one u sub that makes sense in this question. So who is the u sub? Who is the u sub? There's not a lot to pick from, but only one thing works.
Would it be the natural log of x? Because you can't just substitute it with x, and that's kind of the only other term.
Yeah. Do you know that thing? Once you've eliminated all the possibilities, whatever left must be the right answer. In this case, isn't there only 2 choices in picking a u sub equals x? Can you see why a u sub equals x would be pointless? Right, you wouldn't get anything out of it. So now we've got the guy. Let's do step 2. Differentiate with respect to x gets you 1 over x. And when you do your crossover, oh, there's something. I don't need to anymore. Haven't I already got dx on its own just by sheer luck? The minute you've got dx, you've finished. Normally you take 4 steps here, but not this time. Okay, plug it in then. I have 3u over x times x du. Simplify, it becomes that guy. Hey, nice integral, right? Nice simple integral. Power rule. Add 1 to the power, divide by the new power. And then replace the u by log x. There's my step 4 and there's my step 5. Okay, compared to what you were like at the first question, do you feel a little bit more comfortable about how the process works now that you've seen 5 of them? Right. You feel, most of you feel good that way, right? You see what experience, what homework's going to do for you? Because once you've done another 25 of these guys, aren't you going to be even better and more comfortable about doing this process? Right? Now, to me, the biggest problem sometimes is picking the correct u sub. Because if you don't pick the right guy, it doesn't matter what you do, it never works. So choosing the correct u sub is going to be the most vital part of this process. Once you've done that, doesn't the rest kind of, you know, just does its thing and it finishes the way it's going to finish? Most of the time, that's going to be the problem. So what I'm going to do now is I'm going to nip over to the homework, and we are going to look at homework questions, and we're only going to focus on one thing. Who would be the u sub in each of these questions, right? Okay, so I'll zoom up the top. We're looking at 5-5 substitution rule. Right. Probably make this a little bit bigger. Some of the early questions already tell you the u sub, right? So you don't need to worry about it because they tell you what it is. Okay, you see in question 1 then, you're going to integrate this guy and there's your u sub, right? In this question, pretend that wasn't there. Can you see why this would be the u sub? Can you see that when it's, here's some rules for you as we go through them. If it's e to an ugly guy, make the ugly guy your u sub. So if you've got an expression e to the x cubed, e to the power of sine x, right? E to the power of log x, right? E is something ugly. To me, ugly is anything that isn't an x, right? So e to the x cubed, e to the sine x. Make the sine x or the x cubed your u sub. You see this guy inside the square root? Make him your u sub. So whenever you're doing an integral and there's a square root, and inside that square root there's something ugly, you know, x cubed plus 1, 1 plus sine x, you know, anything that's not x essentially, that's a good candidate for your u sub. 90% of the time that's going to work. Trig I'm going to ignore for the time being because trig are special cases. Right, see if you have a fraction like this with nothing else, just one guy over the sign. It's a good idea to pick the bottom guy as your u sub. I guess this one kind of makes sense. Would you agree that the ugly guy is the square root of x? It happens to be in lots of places, but that's what your u sub would be. The guy inside the square root, that's your u sub. Right, here's the beginnings of questions where they don't tell you the u sub. So I'm going to be asking you, who should the u sub be in each case? And 90% of the time, the obvious one is the right one. So we're going to look at that first. And then I'm going to show you some situations where the obvious one doesn't work. And so we kind of need a backup plan. And so you might be thinking, well, how will I know that the obvious one isn't going to work? You won't know until you've tried it. And then 2 lines later, you're going to be looking at an integral that you're going to say, what the heck is that? Because that is garbage. And that's going to be your sign, I've probably picked a bad u sub, right? When you get to about step 2 and you try to do the substitution, nothing comes out good, right? Okay, question 8, who's the u sub?
No one in the square root.
Agreed. Question 9, who's the u sub?
3 minus 4x.
Right? Would you agree things inside brackets are good candidates for u subs? Right, keep going. What about that guy? Who's the u sub in question 10?
The negative t to the 5th power.
Okay. Question 11, who's the u sub?
One plus
Um,
cosine t.
Right,
Yeah.
guy inside the square root. We can do this one. I know it's a trig one and I tend to avoid them tomorrow, but for this trig one, it's okay. Who's the u sub?
4 theta.
Yep. Oh, sometimes the simple ones can catch you. Who's the u sub in 13?
Or x plus 3.
Right, if it's a fraction, pick the guy in the bottom. Who's the u sub in this one? Come on, 3 minus y cubed. Who's the u sub?
3 minus y cubed.
Right, Mia can't be the only one that's doing this. Some of you are just shy. Well done, Mia. I'm skipping 15, it's a trick one. Somebody different. Who is the u sub? Poor me, I'm picking on it. Who's the u sub in question 16?
Minus
Negative
2R.
2R.
Yeah, now we're joining in. Who's the u sub in 17? Just shout it out. Who's the u sub in 17?
Y minus 1 minus e to the u squared.
Oh, don't
Not
use
not
the
the
square.
square. Not the square.
Just don't. If you use the square, it wouldn't work. And then you go back and say, okay, I'll not use the square. So 1 minus u, you corrected it. That one looks ugly. I'll take a volunteer, any volunteer on that one, because that's a stinker. Maybe it's obvious to you. I don't know.
1
X
over
squared.
x squared.
Yes, why that one? Because that's the right answer, because it might not look obvious. A lot of people would probably say, hey, as a fraction, use x cubed, but that doesn't work.
The
I was looking for the
reciprocal-
parentheses.
Right, so 1 over x squared, what? Matthew, did you have an idea why that's the right one?
The reciprocal of the derivative would be x cubed, which would cancel out the x cubed down the bottom.
Yeah. Have you noticed that part of the u sub's job is to kill off what's left? You know, so x squareds tend to kill off x cubes, you know, that kind of thing. Okay. That one looks ridiculous. The answer's actually easy. Anybody? Who's the u sub in 19?
3ax plus bx cubed.
Agreed. Isn't it the guy inside the square root? No matter how weird it looks. And we'll probably, I don't know if we get time, but that one's actually not that bad. It looks horrible, but it's not. Who's the u sub in 20?
2t squared plus 4t minus 3.
Don't you just have to trust the math later on? If we get time, I don't know if I'll do all of these. I probably won't be able to, but that one works. It's a really nice u sub. Oh, here's a sneaky one. Who's the u sub?
The natural log of x.
Why? You're correct. Tell me why you decided that.
It's uglier than the one on the bottom, and it's inside the brackets that's being cubed or something. It's 46 power.
Said it good. 22. Oh God, I like 22. I didn't notice it until I looked at it now. 22.
The cosine of 45x.
Yes. Why? You're right.
Because it's between the brackets and it'll help cancel out the other sign.
You're beginning to think the way I want you to think. You see, when you pick a u sub, there's a couple of different things that you use for clues, and you said all of them there. I'll skip that one by. What about 24?
X plus 8.
Yeah. What about 25? I hate arc cos. It's inverse cos, but whatever. Right. Who's the u sub in 25?
Is it inverse cosine x?
Thank you for changing it to the correct answer. Yes. Do you want to tell me why you picked it? Because it's the right answer. What made you think it was that?
Well, I thought it would either be the one that was connected to the e or
Uh-huh.
the denominator. And I
Right.
chose
So you voted for the top one, and you voted right. If you voted for the bottom one, about 3 lines later into your work, you would realize it was the wrong one, and you go back and fix it, right? Sometimes you have to pick the wrong one when there's 2 good candidates, but you don't know which. Now, after a while, you get the experience and you start realizing, oh, I've done that before, and it was never the square root guy, it was always the e to the ugly guy, and you know, you start picking up some tips that help your life work on. Technically, I would normally miss this one, but you know, because you seem to be getting an knack of it, I'll give you it right now. I normally keep the trick to the end, which would be tomorrow. What would the u sub for this guy be? Because he's not that obvious.
Would it be secant of theta?
That would be a good choice. It doesn't work, but nothing wrong with that. It would be a good choice to try. So since I'm telling you it's not that one, look again. What else could it be?
The tangent, since
Yes.
the tangent's derivative would be secant squared, and the reciprocal of that would cancel out the secant squared.
Okay. So when you're finished, you end up with 9 over u. Right, but sometimes you're going to say secant, that doesn't work, so you go back and look at tan, right? It's okay to have mistakes in these. Who's the u sub in 27?
The inverse tan.
Well done for calling it the right answer. What is the u sub in 28?
Eight to the t.
We're on a roll here, guys. What is the u sub in 29? I hope you're taking note of some of these, because when you do your homework, isn't that going to be the first line? Yeah, to do the u sub. Hopefully you'll remember most of them. What's the u sub in 29?
To the 39th.
20. Did you see the answer there, Matthew? I interrupted you.
Oh, yes. Pi over x to the 39th.
Correct. Who's your u sub in 30?
Nine to the t plus 8.
Yep. I'm skipping 31. It's a trig one. 32 I'm keeping, but it's downright ugly. Who is the u sub in 32?
Natural log of 18.
Yep. 33 is a trick question, so I'm going to write that guy down. 90+% of the questions that you do u subs on, the u sub is either only one possible one, or maybe you've got a choice of a couple, but that's about it. But there is a minority of questions where all the obvious u subs don't work. And those are the, well, for me, they're the fun ones, because they're like puzzles that you have to be sneaky about. I need the u sub for this guy. Let me tell you who doesn't work. I normally would pick the bottom, right? 1 plus x to the 20. That would be a very good candidate for virtually 90+% of situations that look like that. That would work. Can you trust me that it doesn't work, right? Things don't cancel out. You don't end up with a nice integral. So I guess my backup plan would be x to the 9. I think that's pretty obvious, also going to be a failure. And so now you're going to say, well, that's it, we're stuck. Everything I can think of is gone. There is one more guy that I think you might be able to come up with, and he's actually the correct u sub. Can anybody see it? Because this is the first time I've thrown this kind of question at you. Remember, u subs jobs aren't just to make something go away. Shouldn't you also be making the derivative of it go away? Don't know if that was a good clue or not. Here's another clue. It's a power of x. What power of x would be a u sub? So it's not 1 plus something, it's just x to the power of something would work.
X to the power of 10.
Oh, you nailed it. What's good about x to the power of 10?
When you differentiate it, you get x to the power of 9, and it
And
helps
what that
make
makes the
x to
x
the
to the
9.
Yeah, that gets rid of that guy. So let's do it then. Differentiate. You get 10x to the 9. Do the crossover. And then divide both sides by 10x to the 9. And what that does is it isolates my dx. So now I'll go back here. And what do I have? I have an x to the 9 I have a 1 plus somebody, and then I have 1 over 10x to the 9 du. And the problem some of you might have is, but I've got x to the 20, but the u sub isn't x to the 20. The u sub is x to the 10. But isn't u squared x to the 20? And now when I cancel, what I essentially get is 1/10. I like to separate these guys out. I get that guy. Do you recognize that that guy, well, an added a 10th, I guess, but do you recognize 1 over 1 plus u squared? What's the antiderivative of that guy?
Inverse tangent.
And so you have the answer, which you then convert back to the x's. Sneaky. Once you get the u sub sorted out, it's still the 1, 2, 3, 4, 5, right? That's still steps 1, 2, 3, 4, 5, right? I haven't changed the steps, but wasn't that the tricky part? Getting the u sub that's going to work.
Why did you turn x to the 20th into u squared?
Well, on the original question, the guy that looked like that, I need to find how to turn x to the 10s into u's. So I look at that guy, and what I saw was x to the 10 squared. And that meant 1 plus u squared to me. That makes sense? I'm really trying to take all of these x's and turn them into things to do with u's. Now, the x to the 9 guy, he get killed off because of other stuff. So I wasn't so worried about him. Are we good with that, Bobby?
Yeah.
Okay. It's an algebra thing, you know. You got to do what you got to do. Okay, back to, yeah, we got enough time for a few more. Hopefully, we at least get through these as far as the picking the u sub thing goes. Right. In question 34, it's not a u sub question yet. It's a bit of a trick question. What you should do with question 34, it's the only one that we've came to. In fact, it's the only one I think in this whole section, is split it. Split it as an a over 1 plus x squared, and then a total separate one of 7x over 1 plus x squared, right? So 2 separate integrals. So let's focus on the 7x over 1 plus x squared now. What's the u sub that you would use to make that work? 7x on the top, 1 plus x squared on the bottom. Who's the u sub?
The 1 plus x squared.
Okay, back to normal questions now. Question 35, who's your u sub going to be? And just trust your math. Who's the u sub in 35 going to be?
X squared plus 39.
Right. Can you trust me? I'll show you later tomorrow how we fix that, but that's the u sub that works. Would you agree this u sub is just 3t minus 1? All you're going to do is put some numbers in, so I don't count that as a problem. Would you agree this is going to be a u sub of 1 plus 7x? That's a trig one, we'll ignore them. Okay. Who is the u sub going to be in 39? And it is a trick question.
2x.
Oh, I see where you're coming from. Good try.
It's e to the x.
Not, yeah, it's just e to the x. But I can see where your 2x is coming from. Can you trust me, if you do a u sub of e to the x, that just becomes 1 over 1 plus u squared, and you can do it. Oh, last question. What would the u sub in question 40 be?
Sin x.
That's pretty good timing. Will you put your last name space first name That's you doing registration. And that's bye-bye for today. And we will see you tomorrow where we will do substitution with trig and some of those later ones that kind of need a little bit extra work to make them, you know, finish them. As soon as you've done that, it's bye-bye.
Can I ask you 2 quick questions?
Yes, Kira, what you got?
Is the U any kind of special character? I noticed
No.
you keep writing it really like square and funny.
No, I write it square and funny because my U's look like V's. And so I
Oh.
try and make them not look like V's,
Yeah.
which
Oh.
normally isn't a problem unless the original question, the variable is a V, and then it gets really ugly.
Oh, okay, I changed the way I wrote T and I for the same reason. Okay.
So
makes
that's
sense.
all it is.
And then for this came up when I was doing homework 5.4, but is when you have the antiderivative of 1 over x, is it always the natural log of the absolute value?
No, it's not always. Technically, you could make it always, but I think WebAssign isn't even consistent. Sometimes it is, and sometimes it isn't. The only time you really need to make it an absolute value is if you're doing a limit of integration and one of the numbers is negative. That would be the only, or both numbers are negative. That would be the only real terms you need to do it. So I don't really mind if you put it in or don't put it in.
Okay, yeah, I guess it's just, it said to do the absolute value and there wasn't even any limits of integration or anything, so
Yeah,
or why.
I think it's because they decided that that's what they wanted, I guess. That's the only reason.
Are you trying to nudge us for the future? Gotcha.
Well, maybe. Well, the other reason for it is, do you know if you have an integral with square root of x in it, yeah,
Mhm.
and you do it, technically speaking, shouldn't you never use that if x's are negative?
Yeah, that would
But
make sense.
yeah, but we don't stick absolute values in them, do we? We just all accept that you're never going to use it when x is negative.
Yeah, it's like just kind of the implied.
It's implied. So the absolute value of x in the log situation is kind of implied that if you don't need it, don't bother about it. And if you do need it, then stick it in.
Okay, cool. Thank you. That helps.
Okay, you're welcome.
Have a good
Bye-bye.
rest of your day. Bye.
You too.